why I am studying this in pharmacy applications? Why I am studying this in pharmacy? What is the reason? Okay, before I tell textbook applications, you tell me why we are studying this in pharmacy. The size of the particle will affect so many things. Tell me first thing. Very good. Disintegration, dissolution, biology. All are same. Next. Dissolution, solubility same. Still you are in the same path. Next. First it has to soluble. First it has to disintegrate. Then soluble to dissolve or dissolution. Then it has to absorb, bioavailability. Next, tell me in tablet manufacturing. Tablet manufacturing. Okay, we go one by one as per the textbook. What is the first one, madam? Release and dissolution. Drug release and dissolution. See, we have a tablet or we have a capsule. Before going to tablet, we will go to capsule, because in capsule directly I have powder, so which I can relate with. So capsule has powders. Two types of capsules are there. In one capsule, this is the particle size. In another capsule, this is the particle size. Who will dissolve first? One or two? Two. Why? Small size increases surface area. Increase surface area increases interaction with solvent. More interaction with solvent, eventually increasing the solubility. So we need to study the particle size. We need to maintain, we need to control the particle size in the dosage form in order to have good release and dissolution. Release means drug release. Drug has to release from the dosage form. Okay, that is the one thing. For the capsule, come to the tablet. In tablet, first, you know how tablet is prepared? What are the methods? Diploma. Eventually, you need to punch. Before punching, there are methods to granulation and two methods. Tablet can be prepared by preparing granules or direct compression. Powder can be directly compressed to get the tablet. Listen, if anybody gives me powder, she gave me paracetamol, she gave me excipient 1, excipient 2, excipient 3, excipient 4. I mix as per the formula and I prepare a powder. Now I need to decide. I need to punch the tablet. For that, what the first thing I will do? I won't prepare granule. I will take the powder and I will try to punch the powder directly. I will put that powder into the punching machine and I will try to punch the powder. After punching, if the powder, some powders are naturally compressible. They have compressible properties. Means after punching, they will retain their shape. They will remain in tablet shape only. But 95% powders are incompressible. If you compress also, they will become powder. They won't be in the tablet form. The powders which are retaining their shape after compression, we call them as directly compressible powders, because they are directly compressible. Hence, we are called that as directly compressible powders. This you are going to study in Industrial Pharmacy 1 third year. But because it came here, I am telling you. Okay, directly compressible powders. I repeat, if anybody give you drug and excipients, the first thing you do is go and compress the drug and excipient. If it is compressible, no problem. Go ahead with direct compression. go ahead with direct compression. Okay. If it is not compressible, what should I do, sir? Then go for granulation. So what you will do is your powder is converted into granule like this. What is granule, sir? Association of particles. A group of particles associating together. We call them as granule. So this is granule. Now granule has compressible property. By converting into granule, you can increase the compressible property. In the granulation, again we have two types. What are those? Very good. Dry granulation and wet granulation. Granules can be prepared by adding directly by dry granule or by adding some liquid. That liquid is called wet granulation. You can add a liquid and prepare a granule, or you can prepare dry granule. Sir, how to prepare dry granules? We'll see. Take powder, prepare a slug. What do you mean by slug? Is a large tablet, this much big tablet. I will share that video. I will share my video is there on full granulation. I will share that video in the group. Please do watch it. Okay, learn it. You have to be self-interest. You know what is the definition of student? Tell me, what do you mean by student? We use a word C, start with C for student. Not Hindi C, okay. Listen. What is the word we use? Curious. Okay, you should be curious to know what is happening. Please. See, there is one problem with curiosity. I need to cut this. Okay. One problem with curiosity. One girl from first year B Farm, she came to me. She is asking for which textbook to study, which book to study for the preparation of GPAT. That is the blender you are doing in first year. I said her, don't search for the book to study for GPAT. Whatever you are studying, study in a concept way. That what is GPAT. This simple logic you are missing. GPAT, see, you will complete first year, you will complete second year. After going to third year, oh, I have to study for GPAT. Again you study first year. This is what the mistake you people are doing. From the first year itself, whatever you are studying, you need to study in a conceptual way. GPAT studying is not something different. If I am a GPAT question paper setter, I won't set the question paper from maths or physics. No, I will set from the given syllabus. So what is the syllabus? Types of dosage form. If that is the syllabus, I will try to find a difficult question. I will not try to give a direct question. Okay, I will not say that dash is the type dosage form made up of gelatin. You will write capsule. So I won't give this type of questions. I will try to twist it. So while studying, assume yourself as a GPAT question paper setter. After studying the concept, try to twist the concept by yourself. How can I twist this? If I want to set the question, where are the possibilities where I can give the question from this? So study in the mindset of GPAT question paper setter. Then only you can crack that GPAT. It will be very easy. Okay. So don't do this mistake. If even though you are in second year, don't go and take Inamdar textbook or some textbook which is GPAT. What the textbook will give, they will give the concepts in a concise way, so that everything will be at one place. Instead of studying one textbook, all textbook concept given in a concise way, not in a full form, only in a concise form. That you need to study that Inamdar textbook for GPAT preparation. Once you complete your all textbooks, all 4 years textbooks, then only you are eligible to touch that. You got what I am saying? Okay, you don't know basics and you are going to ride the bike. You don't know how to press the clutch and you are sitting on the bike. That's what the mistake you are doing. But good, at least I got one person from first year after so many years asking I want to prepare for GPAT at least. So it shows curious. We need to inculcate this thought of GPAT preparation in your mind. We are successful. That's what we need to do. Please, whatever you are studying, study in a GPAT form. I said her, if you think that she completed first sem, if you think that I got good marks in the first sem, I can crack GPAT, you will fail. I said this to her. Getting marks in writing exam and preparation for writing exam is completely different. Preparation for GPAT. In writing, what you will do, you will be ending up mug up, or you will be ending up remembering the whole in a bulk way. You won't analyze that. That paragraph you won't analyze. You just presume that paragraph and you will omit in the exam. That's all. If I twist somewhere and ask question from that paragraph, you can't able to give the answer. That's what is GPAT. So preparation for GPAT is completely different than preparation for your, what do we say, that subjective examination. Please don't do that mistake. Don't confuse. Totally different things we are doing here. Okay. So what you have to do is, for example, I will tell you, sir, how to. You tell me how to do that. Nothing. I am teaching micromeritics. Okay. After this class, whatever I have taught, sit, study that in the form of GPAT, assuming that you are going to set the question paper. Enough. Over. Study a concept, then think, how can I give question in this? Write the questions. Then check for the previous questions. What is the pattern they are giving? Enough. Once you get the mentality of question paper setter, nobody will teach you this. Nobody will tell you that go and prepare questions. Everybody will tell you read. What I am telling is prepare questions. See, in the learning pyramid, analysis. Creation is the first one. Second one is analysis. The basic is cognition. Your exams are testing your cognitive skills, remembrance skill. But your GPAT is testing your analytical skill. In a pyramid, so we have analysis here. If you do like this is creation, this is analysis. After analyzing only, you are going to create a new thing. So study like that. Okay, come back here. So to prepare granules, I will first go for direct compression. Sir, why you are going for direct compression when we can add liquid and prepare a granule? Why you are going for direct compression? If you add liquid, then what I have to do? I need to dry it. If I add liquid, I need to dry it. What is the best method to dry? Tray dryers. In tray dryers, what is the mechanism? Heat. You have an engineering? Tray dryers, we need to supply heat. If the drug is hydrolyzable, if the drug is undergoing hydrolysis, if the drug is sensitive to heat, what we call the drug? Thermolyable. In that case, you can't go for wet granulation. In wet granulation, we use water. In water, we add binding agent, we'll prepare some gum-like thing, and then we try to prepare a granule. Okay, not pure water. In water, we add some binding agents. So if your drug is thermolyable and if your drug is sensitive to hydrolysis, don't go for wet granulation, go for dry granulation. How to prepare dry granules? Take powder, prepare a large slug. You need to punch there. Big tablet. Instead we have continuous dry granulation where two rollers are revolving like this. Powder is falling here. You will get a sheet like this. And we have hammer mill here. This hammer mill will break that sheet. Okay, whatever the broken, see what I am trying to say is, assume this is a slug, this is a slug. Okay, I will take the slug. If I break the slug, what I am finding here, see some granules are there. Few granules are there. I will sieve, take the granules, then I will punch the tablet. See here, we have some granules. Some fine powder is there along with some fine powder. So you can see 2 or 3 particles here. This is granule. That what is slugging. Prepare a slug, then compress, break it, you'll get a granules. Then after getting the granules, go for normal compression, direct compression. You can observe how that particles are binded together. We have directly compressible binders. We have binders where we use for direct compression. So that binder is able to give gummy property, able to give attachment property to the particles when it is in dry form only. See, generally when the gum is activated, take a dry gum, try to touch it. It is not gummy. When you need to activate the gum, once you add water, the gum will activate. That is in wet granulation. Wet granulation, we add binder along with the water, then we prepare a dough mass, then the dough mass is converted into granule, dry the granules, then punch them. In all this, what I am studying here is micromeritics. This is not important. Here, if the particle size is not uniform, how will you punch tablet? There will be hopper. In industry, they won't punch individual, they won't pour individual unit dose and they will punch. No. Continuously the powder will be coming and it will be punching. If the particle size is not uniform, what is going to happen? Large particles will come first, small particles will come last. So first few batches will be having more dose, last few batches will be having less dose. Gone. The dose uniformity, content uniformity, dose uniformity will be not there if we don't maintain the particle size. Next, what is the next one?
Absorption and reaction.
Same. See, release and dissolution, absorption and drug action, all are same thing. How it starts, we'll try to see. First, tablet will disintegrate into larger particles. Then, one particle will undergo dissolution, converted into molecules. Then, absorption. Release, dissolution, absorption. After absorption, it will show drug action. All these are related. If this particle size is not controlled, if the particle size is large, release will be delayed, absorption will be delayed, drug action will be delayed. If the particle size is small, release will be enhanced, absorption will be enhanced, drug action will be also very fast. Not enhanced, it will be very fast. What is the next one? Physical stability will come under emulsions and suspensions. In suspension and emulsion, you want your dispersed particle in small size. As much small as what? See, in emulsion I said, if the globule size is large, they will undergo coalescence and they will be cracking of the emulsion. So to improve the stability, we convert these globules into smaller, larger globule is converted into smaller globule. Then only your emulsion will be stable. This is one physical stability for emulsion. Same thing. If the suspension we have larger particles, suddenly it will sit. You shake the bottle, before you take your dose, the particle will settle. You will be end up taking only supernatant liquid. You won't take the drug. For that, convert this particle into smaller particles. Convert this particle into smaller particles. If you reduce the size of dispersed particle in suspension, the stability will increase. Next. Yeah, that's what I said here. Dose uniformity. If when filling the capsule or when punching the tablet, the powder will be flowing from the hopper. Okay, hopper means a guide rail which guides the powder. Powder will be flowing from the hopper and it will be coming and pouring into the capsule, or you can say tablet punching machine. If the particle size is not uniform, the drug content will be not uniform. If the particle size is uniform, drug content will be uniform. You tell me which graph represents uniform particle size. Okay. Actually, this has to be taught in the later part of this chapter, but the question arises. So I will take frequency on the y-axis I will take size on the x-axis. We call it as a frequency distributed curve. Where we have uniform particle size. See the x-axis. See the graph and the x-axis. 0, 10, 100. Graph 1. We have this graph covers 10 to 100. So we have particles ranging from 10 to 100. What do you mean by uniform particle size? All should be in the same size. You tell me now which one? 2. Second one. Very good. Second one represent uniform particle size. The graph should be narrow. The graph should be narrow. The graph is broad. See the size. If the graph is broad, see, a picture speaks 1,000 words. You should be able to analyze this. That's what I said, analytical skills. That is very important. Just remembering broad means not uniform, narrow means uniform is a cognition. Still you are in the this of the pyramid, the low level. That is done from the first class itself. It is cognition. Okay. Important is analysis. Come to the higher level of intelligence. Still you people are in lower level of intelligence. If you think that in this intelligence you are getting marks, it is not worth. Important is creation. By your knowledge, you should be able to solve the problem. That much knowledge you need to gain, not to get the marks. Okay, so here, when you see the graph, see the graph is very broad. The size starts from 10 into 100, means we have so much size, broad size distribution. Okay, here we have narrow size distribution. So where could be uniform size? In the narrow. All the particles are in almost in the less size. Hence, there is a chance of more content uniformity in these granules than these granules. If I punch these granules, I won't get content uniformity. If I punch these granules, I will get content uniformity. That's what it is. What is the next one?
Filling and packing.
Filling and packing, same thing. If you want to fill the capsule, if all particles are in same size, it is very easy to fill and pack. See, packing also, if you have same particles, they will pack like this closely. If it has one particles like this, another particle like this, another particle like this, see the packing here and here. If the particle size is uniform, filling and packing is very uniform and easy. If the particle size is non-uniform, filling and packing is not going to very easy. Next one.
Manufacturing process.
Obviously, it is very easy to deal with uniform particle size than with the non-uniform particle size. Next.
Compression properties.
Compression properties. See, in compression, if you have small particles, there is a chance that compression, what is important is, you have two particles like this. If I compress them, they need to attach with each other. During attachment, whatever the surface area is there, that will play more important. If the particle size is large, surface area is less, attachment will also less. If the particle size is small, surface area is more, attachment is more, compression is more. So you will get more compression in uniform or less particle size compared to larger particle size. Next.
Dry powders.
Dry powders. We have powders which undergo hydrolysis. Best example is your penicillin injection, any injection, okay, antibiotics injection. If you go to doctor, if you get any infection, he will try to give you antibiotic injection. In that antibiotic injection, you can found he will write a prescription. You go to chemist, bring that antibiotic. That will be in this much big box. If you open the box, you will find two glasswares there. One is vial, one is ampule. One will be vial, one will be ampule or plastic bag which contains water. The vial contains powder, the bag contains water. Instead of giving the uh, antibiotic in liquid form, if you give antibiotic in liquid form, its storage will be only for 3 months. Stability is only for 3 months. Why? It is undergoing hydrolysis. You are adding water, it is undergoing hydrolysis, it storage time will be not more. If I remove water from the dosage form, if I give water separately, if water is just mixed before injecting, if water is just mixed before injecting, I can increase the stability of dosage form. I can increase the stability of dosage form. We call it as reconstituent liquids or reconstituent dosage form. Reconstituent, again you are mixing, not again, yeah. Initially they will be having water, will remove water and will convert into powder. After, before injecting, again will mix the water. Hence the name reconstituent. Reconstituent powders. So powders are being given in the dry form. Powders are being given in the dry form to increase the drug stability. So to convert that into dry form. Now, which type of dry form powder is mixable? See, once, let's say she is the patient, she brought the antibiotic. Now, two things can happen. Particle size is more in one dry form, particle size is less in another dry form. If doctor adds water to that, which one will dissolve first? More particle size or less particle size? Otherwise, what will happen? After adding water, doctor will ask you, go and have a walk for 1 hour. Then it will dissolve, then I have to inject. To avoid this problem, what we do is reconstituent powders are being given in a less particle size, so that during reconstituents they will dissolve very fast. Then and there itself it will dissolve. Then doctor will take the injection and give the injection. Why we are doing all this nonsense? One, the drug is undergoing hydrolysis. So separate water from it. So how cleverly they are thinking. Okay, you have problem with water, okay, no problem, but you need to drink water. You have problem with water, you need to drink water. Instead of diving into water, I will give water separately. Just when you need, have it. That's all, over. So in the reconstituent powder, if you decrease the particle size, the solubility will increase. There also I need to study about the particle size, hence micrometrics. This, what is the use of micromeritics? This is why we are studying micromeritics in pharmacy.